Masudi here.
Hi guys, Demo from Masudi.
Last session, we worked on converting the incoming JSON from customer to the server, converting it to an order item, and then we added to the orders that we have in the admin side. And this session, first, I'm going to create an executable. Not executable, because you cannot create ordinary executables like other applications. We are going to compile it and like we are going to release it and then run it, and then from there we will continue toward converting it to HTTP server and HTTP client. We are going to apply the HTTP protocol. So I remember it was session 10 or 11 that we released the first version. We compiled it and released a jar file and run it. And I want to do the same here. And as you remember, we tried to compile this project and into, for example, let's say I want you to, include runtime, and the output I want it to be shop.jar, and it compiles. Oh, I should give it the files, of course. I say all the files in this folder, from this folder to all the files and folders in this directory, current working directory in the source here. The dot means all of the files. It is compiling and trying to give a shop.jar output. And we've got a bunch of errors, unresolved reference. Oh, it is not seeing the JSON library because we've added the JSON library. We should also tell the location of all the libraries that we are using. And I remember it is here. It's this jar file. And let's copy and paste it here actually to make it easier. So here I should say that the class path is all the files and folders of the .class files and .jar files that you are passing it to the compiler. When you compile something with Java or Kotlin, you should give all the classes and all the libraries as a parameter to -class path, and then you should, for example, ask it for output for another jar. Okay, we give all the files and folders of .kt files that Kotlin C should compile, and with -cp we give all the libraries that it needs, and then we tell it to include the runtime of Kotlin, and we tell it to output a shop.jar file. Then it tries to compile and make all of it as one unit, as one.jar. Of course, we can tell to include also the classes inside the jar library. So it's here, shop.jar. If we open it, you can see that we have .class files that have been compiled. We don't have .kt. There is no .kt anymore. They are all .classes. For example, inside admin, we have these .class. They are compiled, Java. And this Kotlin here, which is almost 4 megabytes, is the runtime that we told it to include, the runtime of Kotlin. So now, if we want to run it, I want to run it twice. Let me open terminal here. I want to run it as, because it's a Java application after all, java-jar and -cp. Let's say shop. Of course, I should give all the jars here. The JSON is needed for this to run correctly, and it is not included. If we open it, there are a lot of classes inside it. JSON object class, JSON array class. We can make them, we can copy all of this to the other .jar and combine them, even manually with copying and pasting, because jar is a .zip file after all. But let's run it like this. I'm telling all the jar files it needs, and then I tell it, for example, to run admin application. I'm giving the address, the package, and the class file that includes the main function, admin application KT, because it will append. You can see that the Kotlin is appending at admin application KT dot class. Inside this, we know that this is the admin application. We have a main function here. We know it. And it is appending it KT here, KT dot class. So if I run it, unable to access jar file, admin -cp java-jar, and what's going on? -cp. Let's get rid of this jar. Okay, now it's running. Now this is the admin here. If we say, for example, print product list is number 6, nothing is there. There is no product. Let's run it again in another terminal. This time,
custom.
I want to run it as customer java-cp JSON and shop.jar customer. It's customer application KD. Okay. Now if I say, for example, ask product list, it is asking the other side, please give me the product list here. And for example, if I want to, for example, let's here create some product. For example, if we say 1 apple price is 1,000, then again let's create another one, orange 2,000. Now here if I say give me product list, it is giving me the product list, apple 1,000, orange 2,000. And let's place an order. For example, I want 3 apples, yes. I want 6. Oh, I give the product name Ron. Okay. For example, I get 8. Nope. Here it is saying that place order, new order has been received from MassOD. And let's, for example, say here we can see that print pending orders is 0. But if I want to print the menu again, you will see that we have pending order, 1 pending order here. So again, you can see that these two applications are connected to each other. And if I want to prove that, for example, I open another terminal here and I say, because they are, I believe, listening on port 1, 2, 3, 4, 5, and you can see this process here, 6412, is listening on the port 1, 2, 3, 4, 5, and this process 6490 has been connected multiple times and has been closed and is waiting, has been issued multiple connections. And if I open the monitor here, maybe you are using Windows, you can open the task manager. So this process 6412, you can see has been opened, by java-cp admin application. So 6412 process is the admin application, and 6490, this one, is the customer application. So this one is listening. This one has issued multiple connections on that port, and this one is still listening. So they are 2 separate applications that have been connected to each other, and although they are on the same machine, and although you may, for example, say, okay, they are being run from the same jar file. You may, for example, mistakenly say that they are the same process, but we can split the code into 2 into 2 jar files, and prove that they are 2 processes. They are 2 separate applications running as 2 separate processes, and they are connecting to each other. So this is the thing that I wanted to show you, that so we can run this customer application completely on another machine and connect to this machine that the server is running. And we should, of course, because now we are giving the local host, or 127.0.0.1, as the loopback address to the same machine, because they are both running on the same machine. So if we want to run the customer on another machine, we should give the address of the admin machine. Okay, so now let's continue from here. Let me close all of them. If I now say, you can see that there is no processes on port 1, 2, 3, 4, 5. Okay. Now let's get rid of these. Now let's now the server, as you remember, is just it's some kind of it's a protocol that we ourselves created it. It's something new, and we want to use the standard, HTTP protocol here. And every protocol that we use, for example, all over us, in our daily life, for example, FTP, HTTP, or any protocol that we are using, it's been defined somewhere, and they call it the request for comment RFC files. For example, HTTP RFC. If we search for it, you can see that it's 2616. This is the ID of the document that the HTTP Hypertext Transfer Protocol has been defined. So we defined ourselves a new protocol here. The protocol that we had was something like this. Then the connection is made.
Mm-hmm.
Okay, then the connection is made through TCP connection with the socket programming. After that, when we want to talk to each other, we are supposed to talk something like this. If I want to send a command, I have to send it. I have to write my command and then a \n.
Yes.
And then I can include body to this command, and then 2 consecutive \n's means the end of my message.
Yes.
And then I will wait for the response. The response, again, the first line will be the status. I remember the customer here using the connector to send the request will, of course, send it like this. Will first send the command that it received it, so that it's telling that I'm responding to this command.
Mm-hmm.
Then a \n, then the body of the request, then again 2 consecutive \n's. So this is the protocol. And we have, for example, this hypertext transfer protocol we are using every day. This browser now is using this protocol here. And it is almost, I think, let's see. We are not going to cover everything here, but all of the RFC document files almost got the same, If you read one, the rest will be easy. So here it is just trying to define all the terminology and how, for example, what is URL, what is the syntax, and all that. And I want to jump here to HTTP message, to the request here, and then to the response. How is the HTTP request and how is HTTP response? So if I go to here 5, you can see a request message from a client to a server includes within the first line of that message the method to be applied to the resource, the identifier of the resource, and the protocol. So this is the language that they use. They call it BNF, Backus NAR form, and they define, for example, this Kotlin language with with BNF. So a request is request line and multiple. This star means multiple. Multiple headers, or request header or entity header, multiple headers, then a CRLF, then the next header, then a CRLF. CRLF means next line, control line feed. And then if we see another CRLF, it means that we will see the message body. We should send the message body. So again, 2 consecutive \n, you can say. But CRLF is not \n. It's CR. Line feed is \n. CR is character 10, I think. We should send 2 consecutive 10 and 13, the characters. And then the message body. So in our protocol, we had this error that if our message supposed to contain two consecutive backslash n. Say that, for example, we wanted to send some message to the other side, that the message itself contains two backslash n, then the other side, you know, mistakenly could take it as the end of the message. But here, this HTTP protocol has been defined, you know, with having all these things in mind. So here, the request will be the request line. The request line itself, the request line is this: method space request URI space HTTP version, and again a CRLF. So we will see all these in action here, but I wanted to show you. So the method, again, what is this method? The method is one of these: option, get, head, post, put, delete, trace, connect, and any other method that you say, extension. For example, the server has defined some custom method that has not been defined in the HTTP. And the request URI is, of course, for example, absolute path, absolute URI. This the URI itself has an RFC file that you can go and read. And so, for example, this URI that we are issuing on this server, what is the protocol there? You know, all of these has an RFC file for itself, maybe multiple RFCs. And then the option here, the request URI, the HTTP version, and CRLF. And let's go to the response as well. The headers. What are the headers? The accept charset, for example, accept language or range or user agent. You will see all these headers. What is the response? What is the HTTP response? HTTP response will be status line, which is defined here. We will go there. Then multiple headers separated with control line fit. Then again a CRLF, and then the message body in the response. So what is a status line? A status line is HTTP version, space, status code, space, and reason phrase, and then a CRLF. So status code and reason phrase is those, for example, you've seen maybe HTTP 200 404, page not found. You've seen all these 404, for example. When the server is going to return a response to the client, the HTTP protocol has defined some predefined errors or success messages. For example, 200 means okay. If server sends 200 as the status line, status code, the client should consider that, okay, it was okay. 201 is created, it means created. 202 means accepted, for example. And all these, for example, 400 means bad request. 404 means not found, that you've seen it a lot. Or 401 is unauthorized, you've seen it maybe a lot. 403, forbidden. 500 is all these server, internal server, or you may have seen it. Those that begin with 5 are about the errors on the server. So this protocol here, this document is trying to establish a language between two parties that are going to talk to each other. It's saying how a request should be, how the response to that request, what does the status means, for example, how the client should. So, for example, the server and the client should agree that on this endpoint that you are connecting to me, if you send post to me, if everything goes right, I will send, for example, 202. If you receive 202, it means that I accepted your request. If I, for example, send delete to this other endpoint and I send you 200, for example, it means that it was okay. If you send post to this other endpoint, if I send you back 201, it means that I created that JSON that you gave me. Okay. So these should be negotiated between the server and the client. The client should know I will be receiving 201 or 400, for example, to this endpoint that I'm sending. Or if I post to this endpoint, there is nothing, the server is not expecting anything to post on this endpoint. So these should be, again, negotiated between the customer and, the client and the server. And so now that we know how HTTP connection, it's almost maybe 2,000 pages, or I don't know, no, 200 pages. Yes, almost 200 pages. And all of them begin with, for example, what is the terminology. It defines what is firsthand, what are the words that have been used in this document. For example, maybe 20 page lines, 20 pages are about that. Then about, for example, this language BNF that we talked about, how does it work? And then it starts, defining everything. So, but the important part was that request and response. And now let's just see it in action. Okay, can you give me an example of, a HTTP client that you use every day, every maybe hour in your daily life?
Out of programming?
Yes. HTTP client that everybody is using,
When two people see each other.
No, HTTP client. When you use your computer or your mobile, and you are using most of the time, you are using an HTTP client.
When we call someone, that person says hello.
No.
Okay.
I mean this browser. This browser, Chrome browser or Firefox or Safari or anything that you're using, is one of the most common HTTP client. Everything that you are using here, you are issuing a HTTP or HTTPS. You are using HTTP. HTTPS is on HTTP. You are using this HTTP protocol to connect to somewhere, and so this application here, this browser that you have here, is a great example of HTTP client. So anything that we type here is the host and the URL, and I want to actually put it into test. So let's come here to the admin application, and actually let's create another test file that we will delete it later. So let's say test HTTP server. I want to have a main function here, and then I want to create a server socket. I don't know why it's taking too long to, okay, server socket, for example, on port 12345 again, val server, and let's accept the connection again, like we did here, nothing new there. So accept a client, yes. After it is accepted, I want to just get the input stream, the in stream, val in stream, and I want to have a simple while loop and get the read 1 byte at a time, val next byte, and then I want to print it as a character, yes. So we've got a bunch of updates there. To char. We did this before, you remember. So we are creating a server socket which will be listening on this port 12345, and then we will accept an incoming connection. After the connection has been made, then we will get the input stream of that client, and we will listen to everything that comes from the other side, and we will print it here. So I run it now, and I will try to use this browser as the client to my own server, and I want to prove that every time you open a tab on this Chrome browser or any browser, this browser is issuing a socket client to that URL that you are giving, and to the port, of course, and it is sending its request, its HTTP request, in this form that we just saw. So now it's listening here. Just forget about these lines. Let me get rid of this. So when we want to connect to any server, to Google or anything, so let's say we type the first, if we go to the URL RFC or URI, I think, RFC 3986, Uniform Resource Locator. And this is the URL, this is URI. If you go there, you will see that, again, this is a document that is defining how a URL is made. So the URL is, of course, first comes the protocol, then a colon, then 2 slashes, then the address, the server address. Then after that, after a backslash, comes the resource on that server. So when we are creating a URL, we are trying to locate some URL, resource on some machine. First, we will say, okay, the machine that I'm going to talk to you with FTP protocol. So you can, for example, know the FTP protocol. So FTP : // Then what is your address? Okay, I give your IP address or the name that you have reserved in one of the DNS servers. For example, here is tools. Not the tools, it's subdomain, ietf.org. ietf.org will be converted to an IP address. Then, okay, I have your address. Then I should have the process that is running on you that can listen to FTP connection that I'm going to connect. So I'm addressing a specific process on a specific machine. Then after that, I'm telling you, okay, give me this resource, /pictures, for example, cat.jpg, or /do this, for example. So here we can say HTTP. Then I say the address of this machine is localhost, yes, localhost, or we can give 120.127.0.0.1. This address is the loopback. I'm giving the address of the server. Then, what is the port? You've been always giving the port to this browser, but you've never noticed it. If the port is 80, because the HTTP protocol, the standard port that has been accepted globally is 80, you are not. You can ignore it. You can refer to the browser and tell it, okay, put :80 at the end of the host. So this part here is, of course, the address of the server that I'm going to connect. I'm going to connect to a machine with this address and to the process that is listening on port 80. But mine is listening on port 12345, yes?
Yes.
And I'm not going to get any resource here, but let's get rid of this. We will see this later. Let's just connect and see what this Chrome browser as a HTTP client sends to the server every time that we connect. Okay, I connected. You can see here, we have get /HTTP/1.1 host 1.120011235 connection. These are the headers. Then 2 consecutive backslash and 1 here and 1 here. You can see, and it is waiting. It is waiting here. It is waiting, spinning there, waiting for a response. So the browser issued a socket client, a socket connection, a TCP connection to this server, and sent me these. And if we want to come here to section 4 as the request to see if the Chrome is actually doing its job correctly and sending a proper request. It was section 4, I think. Yes, HTTP request here. And a correct HTTP request is, let's see, HTTP message. No, it was section 5. Section 5 was HTTP request, yes. And HTTP request is request line. So the request line is method space request URI space HTTP version and CRLF. Let's see. This is the method. So the method can be one of these. We have get here. So get, then a space. Here we have a space. Then we have the, let's see, we have request URI. We told it to give us what? If we don't give the Chrome, it will append in a slash, not backslash. It will append in slash. So we are asking for the root, and then space, then the HTTP version, HTTP 1.1. Most of the time it's HTTP 1.1, all the browsers and all the we are but HTTP1 is deprecated. They are now replacing HTTP2, and then a CRLF. Let's get back here. Then a CRLF, we have a CRLF as the end of request line. Then the request line finishes. Then we have we could have this star means we could have multiple headers separated with CRLF. So what is a header? It defines the headers, you know, or could be accept char set, could be anything, and we could go and read what does each of them mean. For example, it is saying the host is this, the connection could be the live, then the user agent, we are connecting from Linux, and for example, Chrome version this, something like that. The client Chrome is saying that I accept if you give me HTML, if you give me XML, if you give me these types, I can show them. And I don't know what does these mean. If you give it, for example, content compressed, I can decompress it. If you give in these languages, Persian or English or anything, I will know. So now it is then gives us ending CRLF here, indicating end of message, and then it is waiting here. We have two CRLFs consecutive, and you can see we have. Then the message body, it doesn't contain any message body in this message. Then it is waiting there for us to send a response. Now let's send some response. So when we are going to response, you know, these headers, we can have our own headers. We can send our own headers, but we got certain headers that, you know, have specific meanings. For example, when we are going to send a response, we are going to include content length. I don't see content length here. Maybe it's in the headers of the response. The content length here, yes, means that this body that I'm giving you, that I'm sending back, for example, in bytes, the length of the body that I'm giving back. So now let's send back something to the server. So here I want to say if I see two consecutive /CRLFs, I take it as the end of the message, and then I'm going to send back, for example, a static HTML page. Let's see what happens. So first we should here, let's say that var end of message has been seen equals false. If we see two consecutive CRLFs, then it means the end of the message. So let's say var first CRLF has been seen equals false. Here we will say if next byte equals, I think it's 1013, and I'm not sure. Let's this time print the characters, the bytes, instead of the character form. I just want to see the CRLF. What is the CRLF? Space is character 13, I think 30. Let's run it again. This will stop because we stopped the server. Let's connect again, for example, like if a okay, so it connected again. I don't know why. Oh, because it refreshed itself without me telling it. It just tried to reconnect again to the server. So again, I refresh it. Okay, I'm printing the bytes here. This time I'm not, okay, we have 1310. We have 1310. So it means CR is 13 and line fit is 10, the bytes. So if we say if next byte is 13, and again we should have the next byte, of course. Let's see how we could make it easier here. CRLF. Maybe we could append everything to some kind of string. Var message so far. At first is empty string, then we append it. Message so far. Append the next byte as char. to it, and then we say if message so far contains, for example, contains, or we can say if the index of index of let's say ends with, or ends with backslash n is the character 10, and backslash r will be character 13. So backslash r backslash 2 consecutive CRLFs. If it ends, we want to break from this while true loop, and then we want to send a message to the other side. Let's send a message. So we say client dot get output stream dot write. I want to write a multi-line string, and let's convert it to bytes, of course, to byte array. Now all the backslash ends and everything matters here, because we should follow the protocol. So we should say as a response, let's see how a response should be actually. It was here, section 6 maybe. Yes, response. Response should be a status line, then multiple headers, then 2 consecutive CRLFs. We are not going to send any header. No, we are going to send. We should send the body. We are going to send the body. So the status line will be HTTP version space status code space reason phrase CRLF. So reason phrase is the actually this is, for example, the reason phrase of 200 is okay. Is actually is the term about description of the status. So let's do this. HTTP slash 1.1 space, then status code, let's send 200 space, then reason phrase. The reason phrase of 200 was okay, all capital uppercase, then a CRLF. Yes, CRLF. So CRLF means backslash r and backslash n, and because I've make it multi-line string, let's make it single line, backslash r backslash n. So this is the first line. Then we can have headers, and I'm going to have the content length header, which means something to the client, and we will give the body, the length of the body that we are going to send, and backslash r backslash n, and then the so let's see, 2 consecutive CRLFs, and then the message body. So I don't know if you know anything about HTML.
A little bit.
Let's send some HTML. Let's, for example, something like let's copy and paste the page here, for example. What is the HTML of the Google itself, huh? Let's see, inspect it, and let's copy. We should not inspect it. I think we should view the source code. Google view page source. Yes, this is the HTML, and it includes also the JS files. I don't know if it will be working. Let's test it. I copied it, and let's paste it here. Val Google HTML equals. I paste it here. It will be a lot maybe. It's trying to paste, and it was too much because of the JS files. And okay, now we have it. And now I'm going to send the Google HTML, but before that I want to tell in the content length how much is the length, the size of the in bytes, the size of the body. So the Google let's see, Google HTML dot. We can say size and length, but we should be sure that all the characters here are 1 byte. Because if we, for example, have some character here, like Persian character, because it takes 2 bytes, we should be precise here. So we can say 2 bytes. I want to convert it to bytes, this string, to byte array with the char set UTF-8, and I want to get the length. It is more accurate than getting the length of the string, because some characters may take 2 bytes. It is size, sorry, or let's see if it is size. Okay, then we should finish the client dot disconnect or close. Maybe it's close. Let's run it, hopefully, to see some output here. Okay, we've got a bunch of errors here. Because of these, we should have escaped them. So if we put it in multi-line string, we will not see, because these backslash does mean something here. It is trying to escape. So let me just do this.
There's a page. My homepage I think has a simple HTML.
Let's just first put it in to multi-line string. We will not be seeing these errors. So if we make it a multi-line string, 3 triple quotations, and if we paste the document again, this time we should not have any errors, I believe. Which we have it here and here. It's because, again, this $sign means something.
Mm-hmm.
So if we give again another $sign, no, it means something. What could we do here?
My homepage I think has simple HTML. No?
Your homepage, okay. Let's see.
We had it. It has nothing actually, just a simple HTML.
Let's see.
.ir.
Where is your homepage?
What was that? Demoapp.ir, huh?
Demoapp.ir.
That's so simple.
Okay. So simple.
It's okay, huh?
Yes, it's okay.
We can actually.
Okay, it's okay. Okay, let's close this actually, in this and this, and let's run it. Let's refresh. It is connecting, but maybe we have made mistake in the /r/ns. Let's see if it comes outside of this while loop. Let's run it as debug. Maybe it's, this is /n/r. I've made mistake here. /r/n, /r again, the /n. Let's run it again. So it's okay here, it's okay here. Refresh the page. It's black. It has exited, and why is that? So let's run it as debug again. I just want to see. Refresh. Okay, we are here. The message so far is okay. You can see all the /r and /n. This is the message so far, 2 consecutive. And then we are getting the output stream, and we are trying to write this content length, and then 2 /r/ns. Of course, we have not followed the protocol correctly. So in the response again, we should have 2 consecutive CRLFs and then the message body. And if we refresh, we get your website, because we don't have this picture here, and it is thinking that it's relative to my server, to this machine here, but the picture is not here. So you can see that we connected to this machine, and it responded with HTTP protocol. The HTML content is being sent through HTTP protocol. So we have HTTP server, we have HTTP client. They know what they are doing. They know how to talk to each other. And this port here, for example, if I if I run my server on port 80, which is the standard port for HTTP servers, and permission denied. My machine is not letting me because this port is reserved. I think we can get rid of this. But if we run it on port 80, and if we don't give it the port here after colon, the browser itself will append 80 and behind the scenes and then try to connect. So every time that you are connecting to some machine, every time you are giving a port, even though it's not you that you are typing the port, every time, because you should address a process, a running process in some machine. You should not only address the machine, you should also address the process that is listening on that port. So every time you should give the port, because you are connecting through TCP. You are connecting two processes. The process of Chrome and the process of your server are connecting to each other. So the server should be listening on some specific port, and this client should connect it. So I think this is enough for this session. You just were introduced to the HTTP protocol, and you saw the Chrome as a good known, client that you are using in your daily life every time without even noticing that. And from here on, we will actually use this HTTP protocol to write our own application in a way that we will say, okay, because this browser every time issues a GET request. We will actually write here, use the HTTP server for our own purposes. We will say, okay, if someone gives post to this endpoint, it means that it is trying to, for example, create a product remotely. I will create product, I will return 201. If, for example, wants to log in, so it should issue a request, for example, post request to /login, and it should give, for example, the credentials, the username and password in the header. So I should be waiting in the incoming request. I should see the headers for username or password. Or maybe we have negotiated with the client. If you want to log in, send me a JSON. In that JSON, put username and password. Send that JSON in the body, in the message body. So then me as a server will be waiting on that endpoint. If I see a post on that endpoint, I will get the message body. I will be expecting it to be a JSON because we have negotiated before. And we have negotiated, you should do a post to this endpoint. You should do a GET to this endpoint. When you are issuing a GET to this endpoint, you should send these headers, this message body in this format. You can pass query strings. We will see that you can pass query strings. Query strings are concatenated with, for example, something like this. Question mark. You've seen this. A equals 3 and ampersand. BC equals, for example, username equals. You've seen all this. So the HTTP protocol has been defined in a way that you can send your the parameters of your request either in the query string appended to URL, in the headers, or in the message body. In 3 parts you can negotiate. The server says, okay, send your, for example, the paging stuff in the query string, send your other stuff in the headers. There is no special meaning, no difference in sending the parameters of your request. This is the server that just dictates, you should send it in the headers. Maybe because your message is a lot, send it in the body. Because, for example, when you are downloading something, it's maybe 3 gigabytes. It cannot be come in the headers, because header, if you see the definition, says that it should not be, the value should not be more than 40 kilobytes, I think. When the thing that you are sending to the other side is more than that, of course you should send it in the message body. Or when you are sending as query string, of course it cannot be more than 200 characters, I think. Okay, so from next session we will again work on this HTTP server, on our own HTTP server, and try to refactor the code that we have, the server and the connector, to HTTP server and HTTP connector. Yeah.
Interesting.
Any question?
No. That was completely.
Okay.
Thank you.
Thank you and
Thank you
bye.
for watching. Bye bye.
Bye.